Hello, grade sevens. We are starting chapter 11, and chapter 11 is all about expressions and equations. And really, we're going to be getting into doing, it's, called that, but we're going to be doing algebra, the exciting algebra. So there's expressions and equations. Last chapter we were working with expressions. Excuse these fuzzy words. And just to review what an expression is, as this definition here says, an expression is any single number or variable or a combination of operations involving numbers and variables. So pretty much an expression is anything. It can be the number 5. It can be the variable r. It can be 8t. So the numerical coefficient 8 with the t. So 8 times by t, whatever that variable is. X plus 9 is an expression. 2y minus 7 is an expression. They could be much longer. You could have 8x cubed plus 3y squared minus pi, x plus 2, whatever. They could go on forever. That's an expression. Any combination of numbers and variables and operations. All of those are expressions. So what's the difference between an expression and an equation? Well, an equation is a mathematical statement with two expressions that have the same value. So when things have the same value, we say that they're equal to each other. And in math, we can use an equal sign. So any equation has two expressions. So this expression right here is x plus 2 right here. And another expression, which is just 3. And they're equal to each other. So if there's an equal sign, that makes it an equation. So an equation has two expressions set equal to each other with that equal sign. So x plus 2 is equal to 3. Y minus 7 is equal to negative 4. 3a minus 2 equals a plus 2. So there doesn't always have to be just one number on one side. It could be variables on each side. Or just b equals 4. Those are all equations. Okay, so quickly looking at how we can represent equations and expressions. So here in this first picture here, we have 3 cups, and we have 5 red counters. So red counters are considered positive numbers. But in these 3 cups, there's also maybe some counters in each one. But we don't know how many are in each one of those. We're sort of assuming that in each cup there's the same number of counters, but there's this unknown number of counters in each of these. So these unknowns, these cups, those represent our variables. So we have 3 of those. So this picture shows 3 cups. We can use C as our variable. Whatever number of counters are in those cups, minus those 5 counters. So this picture right here, using cups and counters, when you see questions saying using cups and counters, this is what it's meaning. We can use these cups to represent variables and how many we have. So in this next one, we have 2 cups. So there's 2 unknowns. So that would mean we have 2, so how many cups there are shows us the numerical coefficient that goes in front of the variable. We don't have to use the variable c, we could use the variable n. There's 2n, something in those cups, we don't know. Those 2 cups plus 4, 2n plus 4, well, those together, the amount in the cups and those 4 counters, add up to 2, 4, 6, 8, 10 counters on the other side. So 2n plus 4 is equal to 10. So this first diagram up here shows us an expression. There's no equal sign. This down here with the equal sign is an equation. Now when you have just the expression, so when we look at just the top, could we figure out how many counters are in each one of these cups? No, we can't. There's an unknown amount, and there could be any amount. in each of those. There's no set amount that it has to be. But what about in our equation down here? Could there be could there be any number of counters in each one of these cups? Well, there couldn't be 100 in each cup, because if there was 100, it'd be 100 plus 100 plus 4 is equal to 10. Is that true? No, 100 plus 100 plus 4 is equal to 204. Is 204 equal to 10? No, 204 is not equal to 10. So there cannot be any number of counters in those cups. And some of you can probably figure out, well, how many counters would there have to be in each one of these cups for there to be a total of 10 on this side, as well as 10 counters on this side for it to be equal? Well, if there's 4 counters here, 1, 2, 3, 4, if I added in 5, 6, 7, 8, 9, 10. If I added in 3 in each, now I'd have 10. I'd have 10 on the left side, and I'd have 10 on the right side of my equation, and that equation would be true. The equal sign would be true, that the left side is equal to the right side. So once there's an equal sign, then your variables become a certain number. They can't just be any number anymore, because otherwise that equation will no longer be true. So this is what we're working with now. We're working with equations where we have variables like we did before, but now these variables are going to be, once they're in the equation, they have to be a specific number, and we can find out what they are. Just looking at a couple other ways we can look at equations and expressions. So these equations, you have 3 x's, 1, 2, 3. They're 3 unknowns, so it's 3x. We have these 2 red squares. A red square represents +1. This is from in your textbook. A white square represents -1. So this is 3x. We also have 2 positives, so we're adding 2. And we're saying that that is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 3x plus 2 is equal to 11. And then on the bottom here, we have one variable, so 1x. We don't have to write that 1 in front. When its numerical coefficient is just 1, we could just say there's x, because there's only one of them. Now there's 3 negatives, so you could write this a couple ways. You could say plus -3, but that's also the same. Adding a negative is the same as subtracting a positive, so we can't just say x minus 3 is equal to +4. Okay, so these are just a couple ways that we can demonstrate equations with pictures that you'll be seeing in your textbooks and some of the problems there. So just wanted to quickly go over what those mean. You'll also have to become fairly adept, fairly good at understanding how to turn words into expressions and equations. So I just want to spend a bit of time practicing that. So when I come up to a sentence like this, so 8 less than 4 times a number, and I need to turn that into expression, the first thing I like to do is find what is my variable, and then I work from there. So my variable is 8 less than 4 times a number. I'm not sure what that is. So that's my variable, my unknown. So I can use whatever variable I want. Let's use the variable x. So I have my variable, my number, and then I work at what's closest to that in my question usually. So 4 times a number. 4 times a number I can show as 4x. There would be 4 of them. And then I'm 8 less than 4 times the number. So 4x minus 8 would be how I could write 8 less than 4 times the number. Okay, so you have to find what that variable is, then work off of that what the sentence is saying. So let's look at the sum of x divided by 2 and 8. Okay, so here's my variable x. They give it to me in here. This time they would say a number. But I'm looking at the sum of x divided by 2. Okay, well, the first thing that's being done to x is being divided by 2. So x divided by, I can use that fraction symbol, divided by 2, and 8. So I'm looking for the sum of 2 things. That means I'm adding. So I'm adding x divided by 2. I'm adding to that 8. So there we go. There's my expression. 3 times the result of y minus 4. Okay, this one's a little bit confusing, but again, let's start with our variable. So 3 times the result, y minus 4. So y, I'm going to do what's sort of closest to that, y minus 4, y minus 4. Now I want 3 times what y minus 4 is equal to. I don't know what y minus 4 is equal to, but to show me multiplying what y minus 4 is by 3, I can put brackets around it. And now when I put a 3 outside of it, that means I'm multiplying that whole thing by 3. Or I could still just show y minus 4 in brackets multiplied by 3. So 3 of y minus 4s, whatever that's equal to. Okay? So this is how we can turn each one of these expressions into a written form. And you might want to come back and review this for a couple of the questions that you'll be assigned in the textbook. So those were expressions. Now what if we had to write these equations? So we have to write an equation to match these statements. So there's 2 times a number. Hey, there's my variable, a number, n. 2 times a number, 2n, plus 4, it's equal, that equals 10. So 2 times a number plus 4 equals 10. That one's pretty straightforward. It went in order of how we can show them in our equation. So 2n plus 4 equals 10. How about this one? $30 less than 4 times the cost of a shirt is equal to $50. Okay, a little bit more confusing this time. Let's find our variable. $30 less than 4 times the cost of a shirt. Okay, so the cost of a shirt is our unknown. How much a shirt costs? S. That is unknown. But 4 times the cost of a shirt, so 4s, and $30 less than 4 shirts. 4 times the cost of a shirt, $30 less than that. So $30 less than that would be 4s minus, how do I get rid of this thing? 4s minus 30. Now be careful, just because this is $30 less than, I cannot go 30 minus 4s. This is still figuring out 30 less than 4 times the cost of a shirt. I have to go 4s minus $30, and that is equal to $50. Okay, and there's my equation. So they're not always totally straightforward. Sometimes you have to sort of just find that variable. You always find that variable, and then look in the sentence about what's being done to that variable. Okay, so that's sort of that first section in the textbook. We're doing 2 parts today. So that was going over section 11.1. Now we're going to be talking about section 11.2. Sorry, this is going to be a long video, but with only 2 classes per week this semester, the rest of this term, we sort of need to just clump some more things together. So we're looking at solving one-step equations right now. Solving one-step equations. So equations right now in the form x plus a is equal to b, where a and b are certain numbers. So if that seems confusing, I think the best way to do it is just to show a bunch of examples. You might want to re-watch some of this. Sorry if I'm talking too fast, but that's why it's great. It's a YouTube video. You can always go back and re-watch parts as much as you need to get it. So we're looking at what we were saying before. I was saying before that when there's the equal sign, then the variable has to be a specific number. Okay? So I have this equation, x plus 6 is equal to 10. We could demonstrate this with our teeter-totter. So a teeter-totter is going to be flat across like this one is when both sides are the same amount. So on this one side, I have x, I have an unknown, and I have 6. 1, 2, 3, 4, 5, 6. On this other side, I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Doesn't matter. Okay, so now some of you can probably look at this and you can just think, oh, I know what x has to be. because I know the only thing plus 6 that's equal to 10 is 4. So it's 4 plus 6 equals 10. That's great. That's called solving by inspection, by just looking at the equation and thinking what makes sense to go in there. That's a really good skill to have, to be able to solve it that way. I'm just going to use some of these simpler ones, where I'm sure many of you can solve by inspection, but I'm still going to go through the process of what we're doing to actually find out what x is equal to. So if I had this balanced teeter-totter, let's say I wanted to get what x is equal to, just x, on one side of the teeter-totter. So if I wanted to get just x on this side of the teeter-totter, I would have to take away 6 counters from this side. But if I just took away 6 counters from just the left side here, then my teeter-totter would no longer be very balanced. So to keep it balanced, I would also have to take away 6 counters from the right side. Now, since I took away 6 counters from the left side, I took away 6 counters from the right side, now my teeter-totter should still be balanced. And now I can look. On the one side of my teeter-totter, I have the variable x. On the other side of the teeter-totter, I have 4 counters. And so x is equal to 4. So what I did is I did the opposite, or I did the same thing on both sides, and it was the opposite of what was being done to x. So instead of looking at this diagram, what I did is I said, okay, well, here I have x plus 6. I am going to take away these 6. Now, when I have plus 6 and then I minus 6, they cancel out, and they're no longer there anymore. But I can't just take away 6 from one side and then have it still be balanced. I have to take away 6 from both sides for my teeter-totter to be balanced. So I subtracted 6 from the right side, from 10 as well, which gave me equal to 4. And then in my equation, I got x is equal to, well, 10 minus 6 is 4. So x is equal to 4. Okay, so I do the opposite of what's being done to x, but I have to do it on both sides to make it balanced still. Cool. So let's go over some more examples. I have b plus 14 is equal to 20. Well, I have the 14 with the b. I want to have that b all by itself, see what it's equal to. So I'm going to subtract 14 on the left side, and I'm also going to subtract 14 on the right side. Now, imagining our teeter-totter, if I had my teeter-totter here, and I had b plus 14 and 20 over here, if I took away my 14, I have to take away 14 on this side to keep my teeter-totter balanced. So I'm having to do it always on both sides. So I do it on both sides. Now I can simplify. This side I'm just left with b, because positive 14 minus 14 is equal to 0. This side, the right side, 20 minus 14 is equal to 6. Okay, now why don't I check it? So I can actually go back, and since I said b is equal to 6, that means if I put 6 in place for b, so I go 6 plus 14, whoops, does that equal 20? Yes, 6 plus 14 is 20, so 20 equals 20. I know this seems like a weird step, but it's an important check. Okay, we check and we put what we find as our solution for what the variable is back into the equation, and then we can see if we were right. It seems weird now, but later on when equations are more confusing, it will be helpful. Okay, working over here. So 62 is equal to m plus 25. This time the variable's on the other side. That's fine. I still want to do the opposite of what's being done to the variable. So since m is having plus 25, I'm going to subtract 25 because I want to get the m all by itself on that side. I'm going to subtract 25 on this side. So I did the same thing on both sides, minus 25 on both sides. Okay, so these become 0. I'm just left with m on that side, and m is equal to 62 minus 25. You could do your quick math and borrow. This becomes 5. That's 12. So that becomes a 7. 5 minus 2 is 3. So 37 is equal to m. Now, is that right? Let's check. Well, we said 62 is equal to, well, I said m is equal to 37, so I put 37 in place. I'm putting that in place for m. So 37 plus 25. Now I think, okay, well, what is 37 plus 25? I add them together, and I see, oh, hey, that's equal to 62, which means my left side and my right side are equal. which means that 37 has to be the correct solution for n. Okay, scrolling down just a little bit here. Maybe I'll move this down. There we go. Okay, x minus 8 is equal to 31. This time there's a number being subtracted from 8. I still just do the opposite of what's being done to x. So this time I add 8, and I add 8 on the right side as well. So I added 8 on both sides. The same thing on both sides is great, keeps it balanced. But this negative 8, positive 8 cancel out. I'm left with x is equal to 31 plus 8 is 39. There we go. Let's double check. Put 39 back into I can put it back into the equation. 39 minus 8 is equal to 31. What is 39 minus 8 equal to? 39 minus 8 is equal to 31. 31 equals 31. The left and the right side of the equation are equal to each other. Therefore, my solution was correct. So this is just how we check that our answer is correct. So when in the textbook it says, check that your answer is correct, it's asking you to actually just substitute what you found as your solution for the variable back into the equation. Okay, over here, j minus 16 is equal to 8. So j minus 16 equals 8. Some of you can maybe just think what that number is b. That's great. That's solving by inspection. It's good to get used to this method, though. It's not a negative sign. Of doing the opposite operation. So whatever's being done to j is having 16 subtracted from it. So I'm going to add 16 to that side. I'm going to add 16 to this side. These 16s cancel out. Negative 16, positive 16 cancel out. I'm left with j is equal to 8 plus 16 is 24. Now I need to double check. Is j actually equal to 24? I put 24 in place for j. 24 minus 16 is equal to 8. Does 24 minus 16, does that equal 8? Yes, it does. 8 is equal to 8. Yes, the left side of my equation is equal to the right side. That is how I check and see if I am correct. Okay, sort of weird to be like doing this whole check thing. It seems right now might seem sort of useless to you guys, but it actually is a very important step to make sure you're getting your answers correct. Okay, let's keep going. We can get a little bit more complicated here. So f minus 27 is equal to 55. So something minus 27 equals 55. So that must be a number bigger than 55. In fact, it's 27 more than 55. When we add 27 on this side, do the opposite of what's being done to f. F is having 27 subtracted from it. I will add 27. I will do that to both sides to keep my equation balanced. I like to write it right underneath. Okay, and you might want to, like, sometimes you might want to sort of, you guys think like, oh, I'll just write it right here, and then write it right here. That can sometimes be okay, but I would suggest, as we go on, there's going to be reason for this, but to do it right underneath. So I add 27 underneath, and I add 27 underneath. These cancel out. Now I rewrite. I am left with f is equal to, well, 55 plus 27. Well, 55 plus 20 is 75. So plus another 7 from there would be 82. Okay, there's my answer. I'm going to keep going because I think this video is going quite long. I have 12 is equal to b plus 20. This one's weird. Something plus 20 is equal to 12. That's weird because 20 is bigger than 12. Well, let's see what happens if we just follow our steps. I subtract 20 from b because it's having added 20 added to it. I do that to the other side as well. I minus 20. The positive 20, negative 20, they cancel out. So I'm left with just b on this side. On the other side, I have 12 minus 20. Now you're having to bring your brain all the way back to the beginning of the school year when we went over integers and remember how to do that. Well, if I had 12 and I'm subtracting 20, that's actually going to bring me into the negatives. 12 minus 12 is 0. So if I subtract more than 12, I'm going into the negatives. And negative 20 is actually 8 more than 12. So I went back into to negative 8. So b is equal to negative 8. Hopefully you can sort of remember adding and subtracting integers. You might need to review some of that because that can be a bit hard. So 12 minus 20 is equal to negative 8. And now I can check. Does this make sense? 12 is equal to, well, I said negative 8 was equal to b, so negative 8 plus 20. What's negative 8 plus 20? Well, hey, that's actually equal to 12. So 12 is equal to 12. The two sides of my equation are equal. That means they're balanced. That means negative 8 is the answer for what b, the value b is. Okay, d minus 3 over here. D minus 3 is equal to negative 5. Again, a weird one because there's some negatives, but just follow the steps. D, I'm going to add 3. I'm going to add 3 on the other side. Keeps my seesaw teeter-totter balance, so it's still an equal equation. These ones cancel out. I am left with D is equal to, well, negative 5, and I'm adding 3, so it's going to get bigger. And that brings me, if I imagine my number line where negative 5 is, that brings me up to negative 2. Okay, so D is equal to negative 2. Last one here, 24 minus x is equal to 3. This one's a weird one, so it's a little bit tricky. I decided to be a little bit tricky here. So if I have 24 minus x, that's equal to 3. So I need to do the opposite of what is being done to x. Now it's important to remember that 24 here, it's not x minus 24. So if I added 24 here, if I added 24 and I added 24, I couldn't cancel these out because 24 plus 24, remember this is a positive 24, it's not a negative 24. So 24 plus 24 is actually equal to 48. So that would give me 48 minus x. I don't want to have 48 minus x. I want to get the x all by itself. So since there is a positive 24 on the left side, I'm actually just going to put in a negative 24. It's not really that we're adding and subtracting. It's actually more that we're just having positives and negatives cancel each other out. And subtracting a number is like having a negative amount of that number. So if I have positive 24, if I subtract 24 from both sides, subtract 24, or put in 24 negatives, this positive 24 and the negative 24 will cancel out. 3 minus 24 is equal to negative 21. Okay? And now I'm left with this x. But I haven't yet gotten rid of this little subtraction sign, which, is actually just a negative sign. So it's negative x is equal to negative 21. Well, if negative x is equal to negative 21, then positive x, or just x, would have to be equal to positive 21. Okay? So that's a little bit confusing. Now, some of you might be thinking like, well, how does minus x suddenly become negative x? That's just remembering back to our rules with integers where subtracting a positive number is the same as adding a negative number. So anytime you see subtract x, that's actually the same as 24 plus negative x. Okay, so we actually have a negative x here when this other number gets taken away. It's not a positive x. Okay, so a little bit confusing, I know. You have to be able to remember integers right now as well. But the opposite of a negative is a positive. So if I have negative x, the opposite of that is positive x. That's what I'm trying to find. So the opposite of negative 21 would be positive 21. So I got x, and positive x is just x. X is equal to 21. I can check that into my equation. Put that in for x. 24 minus 21 equals 3. Yeah, lots of you probably saw by inspection. You knew what the answer was. And 24 minus 21 is 3. So 3 is equal to 3. So yes, check. My equation is correct when x is equal to 3. Okay, so I'm just going to end there. Actually, I had a couple more. If you guys want to give them a shot right now, you can. I will just quickly put in the solutions, but I'm not going to go over them. They're a couple sort of tricky ones, so don't be worried if you don't get it, but you'd just be doing the same thing. You could have paused. Maybe pause now before you do this last one to see if you can get this one, but I'm just going to quickly do it. Minus 3 minus 3 So negative x is equal to 18. Therefore, positive x, the opposite of x, will be equal to negative 18. Now, when I put in that x is equal to negative 18 into my equation, I get 3 minus negative 18, which is equal to 21. Don't forget that x is equal to negative 18. So just this is equal to negative 18. That subtraction symbol is still there. 3 minus a negative, subtracting a negative, the same as adding the positive. So this is like 3 plus 18, which is equal to 21. So 21 is equal to 21. Okay, so don't worry if these couple are a little bit hard for you right now. You're going to be practicing, and you will be getting better at doing these. So for now, be focusing on being able to follow these steps and do it with these types of problems. Make sure to check in with Mr. Lob or myself if you have any questions. Do the work in the textbook, checking your answers in the back, working with each other. Find a friend if you want to FaceTime with them or have a Google Meet with them to work on it together. Mr. Lob and I will be available, and then also complete the Google form. Good luck, grade 7s. Don't let this seem too daunting. All of you can do this. If you're just doing it by inspection, so you're just looking at it and just thinking what the number should be, then able to figure out that way, that's a great skill to have, but it's really good and really important to be able to follow these steps that I've been showing, so make sure you practice doing that as well. And have a good night. Sorry for the extremely long video.